In the previous video we proved this one. So if we assume that there is a constant epsilon which is greater than 0, and there is another constant delta which is dependent on epsilon, which is also greater than 0, delta is also less than equals to 1, and then if we say that delta is defined as this one, this relation, this inequality, then in order to prove this one we need to show that x square minus 5 less than epsilon. Basically this one minus, so the difference between this and this is less than epsilon, and epsilon delta has to have a dependence on epsilon, so we can define delta on epsilon. So when we did that, we saw that if delta is equals to epsilon over 3 or 1, whichever is minimum, then we can have this one, we can show this one. So in this one what we will do, we will take some numerical values and see whether we can get there. So let's say we want to have this less than 0.03. So epsilon is 0.03. If epsilon is 0.03, delta becomes 0.01. So now it becomes easy to select the value of delta, because minimum between 1 and 0.01 is of course 0.01, so we use that. So we have now x minus 1 is less than 0.01. From here we can get the value of the range of x, the domain of x basically. So what we can do here is first we can take the plus sign, so it will become x minus 1 0.01. so this is 1 here, x here, 1.01, and if we take the negative sign, this becomes minus x plus 1.01. so this is minus 1 minus x 0.99 minus, so it becomes 0.99 x and 1. So together we can say that x has to be within this. However, x cannot be 1, so that we have to remember. So this is what we can have for x. Now let's try something within this range. So what we will do, if we take x to be 1.005, and we will see what we get for this one, minus 5. So this is 1.005 square minus 1, and we can see that this one is 0.01 something. So basically this is less than 0.03. so we can try other values within this range, and we will see that so basically we will need this one. This has to be less than the magnitude. Basically here also it's the magnitude. So whatever value we take, we will see that this one will be, we can check with you can try with other numbers, and we will see within the range of course, and we will see that this relation will always be this one will always be less than 0.03. so yeah, this is we can do with the numerical values, just to show that it works.